There's a spare tire sitting in your trunk right now, next to a jack and a wrench, and you've been hauling that kit around for one simple reason. The 4 tires holding your car up are rubber bags full of pressurized air, and a single nail can empty one in about 30 seconds. That design is quietly expensive on a scale most people never add up. Roughly 1 in 5 tires on the planet gets thrown away before it's actually worn out. About 12% scrapped from flats and blowouts. Another 8% destroyed by uneven wear from the wrong pressure. That doesn't count the tow trucks, the missed flights, or the fleets keeping crews on payroll for no reason other than that vehicles keep going flat. Now picture a tire you could drive a nail straight through, and just keep driving. No warning light, no pulling over, no kneeling on wet gravel on the shoulder. That tire already exists. It's already been driven on an ordinary passenger car at 130 miles per hour, backed by more than 50 patents of engineering. So why isn't it under your car yet? The answer has almost nothing to do with whether the thing works, and almost everything to do with a factory floor. And it's the reason Chinese manufacturers may end up deciding when the rest of us finally get one. Start with what's inside a normal tire, because the design is older than almost anything else on your car. Slice the side away, and what you'd find is an empty chamber full of squeezed air, because that air is what's actually carrying the weight of your vehicle. The rubber around it is just a tough container keeping that air trapped in place. That's the design the Michelin brothers came up with in the 1890s, and it has barely changed since, because squeezed air is springy, light, cheap, and smooths out a rough road better than almost anything else engineers have found. Look through an airless tire instead, and there's no chamber at all. What you see is a web of flexible spokes, fanning out from the wheel rim to the outer band, sometimes shaped like a honeycomb, molded from engineered plastic or fiber-reinforced rubber. Those spokes do the exact job the air used to do. When the wheel rolls over a bump, the spokes touching the road flex, absorb the impact, and snap back into shape as the wheel keeps turning. The weight rides on the structure itself, instead of on trapped gas. And because that support is built into the material, rather than sealed inside a chamber, there's nothing left that can leak or blow out. Put a nail through the tread, and all you have is a tire with a hole in it that keeps working exactly like it did the day before. It would be easy to assume this is one company's pet project, but almost every serious tire maker on Earth has been chasing the same idea. Michelin's version for passenger cars pairs an aluminum wheel with fiber-reinforced rubber, carries roughly 50 patents, and is the one tested at 130 miles per hour. What surprised me most is that on some designs, the tread is a separate, replaceable band, so when the rubber wears down, you swap just that surface and keep the structure underneath. The way you'd resole a good pair of boots instead of throwing out the whole shoe. Michelin's own estimate is that eliminating flats and pressure problems could stop as many as 200 million tires a year from being scrapped early, about 2 million tons of material, roughly the weight of 200 Eiffel Towers, staying out of landfills every year. This isn't a rough prototype. It's solved engineering with enormous stakes attached, which makes the obvious question land harder. If it works this well, somebody should already be selling it to you. And somebody tried. About 20 years ago, the car industry took a serious swing at killing the flat tire, and drivers hated the result enough that many paid money to have it removed. You've probably heard of run-flat tires. If you drive a BMW or a Mercedes, there's a decent chance you're riding on them now. Instead of removing the air, manufacturers thickened the sidewalls enough to hold the car up for another 30 to 50 miles after a puncture, which sounds clever until you realize those same stiff sidewalls are stiff the rest of the time too, so the ride got noticeably harsher. The tires cost anywhere from 35 to 200% more, some running between $150 and $500 each, and wore out sooner, in some cases up to 6,000 miles earlier. Most can't even be patched after a puncture, so a nail that would have cost $20 and a plug on a normal tire now costs an entire new tire. The market reaction was blunt. Dealers report that swapping run flats for conventional tires is one of the first things many new owners do. That failure matters. Not because it makes airless tires look bad, but because it shows exactly what the market will and won't tolerate. Drivers want the flat tire problem solved, but won't accept a worse ride, a higher price, and an unrepairable tire as the cost of solving it. Run flats ask people to pay more for less. An airless tire at the right price does the opposite, which is exactly why price is the entire question left standing. And that question is being answered about 7,000 miles from Detroit. It's the price, and China has rewritten that ending for one industry after another. Michelin just broke into the global top 10 tire brands for the first time, pushing out Japan's Toyo. Chinese tires now sell for roughly 15% less than European or American equivalents at similar performance, which stopped being a story about cheap knockoffs long ago and became a story about an entire supply chain inside one country that can fill an order in 30 to 45 days. Lay the Airless tire on top of that manufacturing base, and it's easy to see why it fits. A regular tire is built from steel belts, fabric layers, and several rubber compounds stacked together and cooked, a complicated process with plenty of ways to go wrong. Many Airless designs are the opposite, essentially molded, meaning you inject engineered plastic into a mold and a finished tire comes out. Molding things at enormous volume for very little cost is exactly what Chinese factories have spent 30 years becoming the best on the planet at. The same pattern that played out with solar panels and electric vehicle batteries. Both expensive for decades, until Chinese factories built them at scale and the price collapsed. And what most people miss is that, while everyone's been watching to see which company puts an Airless tire on a car first, China quietly skipped that race. Chinese manufacturers are already turning out Airless tires by the enormous batch for scooters, delivery carts, warehouse robots, forklifts, and self-driving delivery vehicles in Chinese cities. There's a reason those vehicles went first, and it has nothing to do with technology. A flat costs a company running 100,000 rental bikes real money, since every vehicle sitting idle earns nothing while someone drives out to fix it. Airless tires erase that cost overnight, which is why the switch happened fast and at enormous scale, mostly unnoticed outside China. Every one of those wheels is practice, and it all points straight at the biggest prize in the industry, the 4 tires under your car. So, the technology works, the manufacturing muscle exists, and the demand is obvious. Which brings me to the honest part. 3 specific problems still stand between where things are now and a tire that genuinely can't go flat under your car, and the third one caught me off guard. The first is heat. An Airless tire is a dense structure that flexes constantly, generating heat with nowhere convenient to go. At forklift and scooter speeds, that matters not at all, which is why those vehicles switched over years ago. At 75 miles per hour for 4 straight hours across a hot highway, it becomes a genuine engineering problem, and it's a main reason these designs have struggled to jump from slow vehicles to highway ones. The second is weight. Swapping air for physical structure means adding material, so Airless tires tend to come out heavier, hurting fuel economy, and on an electric vehicle, where engineers fight over every pound of range, that's a real obstacle. The third is debris, and it's the one almost nobody predicts. The open gaps between the spokes that make the tire work also pack solid with mud, snow, gravel, and road salt, and a tire loaded unevenly with frozen slush is felt as a shake in the steering wheel at highway speed. Engineers are working on covers to handle it, but it's awkward precisely because that openness is the entire point of the design. And a tire is a legally regulated safety part, so any new design has to prove itself through years of testing before anyone's allowed to sell it for road use. Michelin originally aimed for its Airless tire to be on sale by 2024, and it still hasn't landed as something you can walk into a shop and buy, which tells you how hard that final stretch really is. To be fair to the companies grinding through this, they're not being slow for no reason. Your tires are the only thing connecting a 2-ton vehicle, carrying your family to the road, and they have to work in 100-degree heat and on sheet ice at 80 miles per hour, after 5 years of being ignored, with a pothole waiting around any corner. Getting confident about that takes a staggering amount of testing. That's a lot of engineering to sit with, and if you've stayed with me this far into a video about tires, you're exactly the kind of person this channel is for. If you want more of this, breaking down the real mechanics behind the technology and history that quietly shapes ordinary life, there's a small community of people supporting that work directly through a Ko-fi link in the description. It's genuinely optional. It costs nothing to just keep watching. And either way, I'm glad you're here. Notice what's missing from that list of 3 problems, though. Not one of them is a question about whether the idea works. Heat is a materials problem. Weight is a design problem. Debris is a shape problem. All 3 get solved by building a few million of something and watching what breaks, which is exactly what Chinese factories are already doing every day on scooters and delivery carts, while everyone else runs careful trials. So no, you can't walk in and buy flat-proof tires this weekend, and anyone promising them by next spring is guessing. But what's actually true here is more interesting than the hype, because the technology works and it's already been proven at highway speed. What's left is heat, weight, and price, not whether the idea holds together. And if the pattern holds the way it did with solar panels and batteries, the road to your driveway almost certainly doesn't run through an expensive launch on a European luxury car. It runs through Chinese factories, molding these things by the tens of millions for scooters and delivery fleets, until the cost has collapsed, then climbing into passenger cars from underneath. The tire on your car right now is a 130-year-old design, and its greatest strength and its only real weakness happen to be the exact same thing. It's held up by air. Take the air out, and the flat tire stops existing as a problem at all. And that spare in your trunk becomes as much of a relic as a hand crank on the front of a car. The engineering to make that happen is essentially finished. What's left gets decided in factories, not laboratories. I'd genuinely like to know what you think. Would you put airless tires on your own car if they showed up tomorrow at the same price as the ones you're driving on now? Or is 130 years of air just too hard to give up? I go back and forth on it myself. Stay curious, stay informed, and I'll see you in the next one.